All right, guys, let's see what we have. Story problem time. Okay. I don't know why they chose to place this in the section that it did. Maybe because it has, like, pieces of expressions and you put them together. But we'll see. We'll give it a try here. All right. So Sarah has 10 pounds of dried fruit selling for $6.25 a pound. She wants to know how many pounds of mixed nuts selling that for $4.50 a pound she would need in order to make a trail mix that would average out to $5 a pound. Trail mix be dried fruit and mixed nuts. Okay, so they recommend making a table for this to kind of organize your information. And let M equal the number of pounds of mixed nuts, because we already know pounds of dried fruit. We have 10 pounds. 10 pounds of dried fruit at $6.25 a pound for a total price of $62.25. No, 50 cents. Slide that decimal over. 62.50. Okay. Mixed nuts. What do we have there? Well, she wants to know how many pounds of mixed nuts. So that's the mystery number, M. And the price per pound is $4.50. So we'd have 4.5 times M. And then the trail mix is kind of the total, right? You combine your mixed nuts and dried fruit into one big bowl or big container, and that's going to be your trail mix. So I'm going to put, it's like a total. This is the total one. So total pounds of trail mix, well, the 10 pounds of dried fruit, plus however many pounds of mixed nuts we had. M plus 10. Okay, the price per pound that we want to average it out to be is $5 a pound. That's what we're trying to get to. And then the total price. So the total price would be 5 times M plus 10. Or you can do it this way, adding down. If you add this down, we have 4.5 times M plus 62.50. Right? The total price, I would have spent $62.50 on dried fruit and 4.5 M on the mixed nuts. Okay. Write a rational expression using the last column on the table. Well, we just did that. So they must have wanted us to go 5.0 times M plus 10 here. So using the last column of the table, we had 62.50 plus 4.5 M. Okay. Also, we had this for the total price of the trail mix. So what you're getting here is a total price of the trail mix going this way and a total price of the trail mix going this way. The total price for the trail mix should be the same thing, and then we're going to set those equal to each other. So going vertically, here's how we got our price, 62.50 plus 4.5 M. Going horizontally, here's our price of M plus 10 times 5. $5 a pound, which is going to be 5M plus 50. So these two quantities should be the same. So that's how we're going to solve. 62.50 plus 4.5M should also equal 5M plus 50. I'm going to subtract the 4.5, so now this is a 0.5 M, right? 5 minus 4.5. And if I subtract the 50 over, 62.50 minus big 50 is going to be 12.50. Okay, divide by 0.5. What happens when you divide by 0.5? Dividing by a half. Think about our fraction work we just did. When you divide by a fraction, it's the same as multiplying by the reciprocal. So if I'm dividing by a half, I'm really going to multiply by 2. My M is 25 pounds of mixed nuts. Don't believe me? You can type it into the calculator. 1250 divided by 0.5, which is the same as a half, and we should get 25 pounds. Okay, another one. What do we got here? Alicia's average speed of riding her bike is 11.5 miles per hour. I'm not sure if that's fast or not. I'm not a big bike rider. We'll say that's pretty fast. 11.5 miles per hour. She takes a round trip of 40 miles, okay? And what they're not telling you here is that this is like an out and back round trip. This isn't like a loop around like several blocks. This is like you're on the trail and you go down to a certain spot, stop, and come back. Not a big loop like around the city, okay? So think of it as a straight line out and back. It takes her 1 hour and 20 minutes with the wind, and 2 hours and 30 minutes to go the same distance against the wind. Okay, so this might require knowledge of a certain formula called DIRT. D equals R times T. Distance equals rate times time. Okay, write an expression for Alicia's time with the wind. Okay, with the wind. So we can move these around. I'm just going to do it like this, just exactly as it is right here. Distance was 20 miles out. Her rate or her speed was 11.5 with the wind, so plus the wind speed, plus W. And her time, 1 hour and 20 minutes. So here's what we're going to need to do. You're going to need to convert these all to hours or all to minutes. Okay? Because hours and minutes is going to be a little messy. So let's just go with hours. What's 20 minutes? What part of an hour is 20 minutes? 20 minutes out of 60 minutes, that's 1/3. So we got 1.3 repeating for our time in that spot. Okay? Against the wind, again, we went 20 miles for our distance. Our rate this time was 11.5 minus the wind. The wind is fighting us this time. It's slowing us down. And it took us 2 hours and 30 minutes, which is 2.5 hours. How long does it take to complete the trip? Well, that's some easy addition there, huh? 1 hour and 20 minutes, 2 hours and 30 minutes. This should be 3 hours and 50 minutes. Okay, write a rational expression to solve for the W. Okay, so look at these two equations that we wrote up here. 20 equals 11.5 plus W times 1.3 repeating. 20 equals 11.5 minus W times 2.5. Both of these equations are equal to 20. So if this is equal to 20 and this is equal to 20, those two should equal each other. 11.5 plus W times 1.3 repeating is equal to 11.5 minus W times 2.5. Alright, so this 0.3 repeating is not going to be the prettiest math in the world, but we'll get by, okay? So I multiply this out. We're going to get 15.3 repeating plus 1.3W, 1.3 repeating. Over here we have 28.75 minus 2.5W. Okay, I like to keep things positive, so we're going to add the 2.5W to both sides. And we're going to subtract this 15.3 repeating. Alright, so this is where it's going to get a little ugly. Okay, so our total W's is going to be 3.83 repeating. And then the number over here, if you type this in, of 28.75 minus 15.3 repeating. Should be in the ballpark here, like 13. I got 13.416 written down from last year. If we divide by 3.83, repeating on the 3, W should equal 3.5 miles per hour. So, not a very strong wind, but you can see it did have a pretty big effect on the amount of time. 3.5 miles an hour, man, for like track and field, that'd be great. 3.5 if we only had that little teeny tiny wind. But when you're going to be riding for such a long time, then that really comes into play a lot. So maybe she's not riding very fast. I don't know. So there you guys go. 2 of those. A lot of things about making tables and finding ways to write it instead of equal to each other and solve. All right. Thanks a lot, guys. Thanks for watching. Let me know if you have any questions. Best of luck.